Okay, hi everybody. I'm Matt Clark, and I'm going to be talking about the Bioscape project. And I just want to say at the get-go, this is under an umbrella project funded by NASA at the United States called Bioscape. And it's a big biodiversity survey of the Cape region. And we're just one of 16 projects under this umbrella project. And so if you wanted to know more about that, come talk to me as well at my poster. Okay. So this is Biosoundscape, and we're focused on, hang on, how do you advance? I'm having the same issue. Oh, there we go, okay. So we're focused on sounds and trying to relate the sounds to animal diversity that we can then relate to some really sophisticated remote sensing. And I have a whole range of collaborators. Maybe some of you know some of these people. But it's basically South African collaborators as well as collaborators in the United States. So I'm actually a remote sensing scientist, and I've gotten into acoustics because this is an amazing way to get in situ, ground-based data on biodiversity, and that we can then link to remote sensing. So NASA came to the Cape region in November 2023 and flew these large orange boxes that you see in that map with this hyperspectral sensor. So it's measuring many, many different parts of the spectrum so we can get spectral diversity. And most of the projects are looking at vegetation diversity, but we're looking at how we can link animal diversity to these kinds of data and make maps of biodiversity kind of in a more automated, remote way. So the poster for this conference, I'm going to be talking about the development of a CNN. Or AI model, which you learned about yesterday with Raven. We basically retrain or fine-tune BirdNet to detect bird, frog, and insect species, as well as broad soundscape components. So these are two different AI models. And so we do anthropophony, human noises, biophony, birds, frogs, and insects, mammals like dogs, geophony, wind and rain, and interference, which is like the knocking sound on your recorder, especially when there's rain or wind. And the big motivation for getting these kind of soundscape components is that we had a wet season campaign. It had a lot of rain kind of interference in our data. And so it's like, well, we need a way to try to filter that out because a larger objective of the project is to look at broad acoustic indices and deep learning features for biodiversity. And so we wanted a kind of a filtering step. But we also are interested in these kind of species through AI. So the question here for the poster is, how do these soundscape components affect the accuracy of our species levels deep learning model? And I jumped over that slide with the map, and I'm not going to try and go back, but I just should say that we had a massive field campaign with a wet and dry season, about 500 sites in each campaign co-located. So it's an amazing data set. That's going to be freely available online through a NASA server. So anybody that's interested in collaborating, or you don't even have to collaborate, it's going to be freely available. But I would love to talk to you how to use these data for your own applications. There's lots of different animals, sounds recorded in those data, and it's across the whole Cape region. Okay, so with the deep learning, we had these two CNNs. We had a huge amount of work to get reference data. This is a big part of deep learning, is just getting the labeled data that you can then go to for your own kind of application. And then we trained BirdNet. So we basically took the features from BirdNet and then kind of fine-tuned it for our own species and these big, broad classes. Okay, so the final punchline I'll just leave you with is, if you look at the upper left figure, this is a it's a multivariate model. It's a generalized linear mixed effect logistic model. We're just predicting the true positives, like presence, absence, as a logistic model, and the effect of these different factors on your ability to detect species, true or not true, false. So for true positive detection, if you look at the upper left, if you increase your confidence in the species model, you get better true positives, which makes sense. The more confidence you choose, more true positives. As we get more confident in predicting anthropophony, which means there's more anthropophony prevalent in our soundscapes, that decreases our ability to detect species. That's what that middle down arrow is. So anthropophony is having an effect on our ability to detect species significantly. Also interference. And surprisingly, geophony was not significant. Of all the factors, I thought that was going to affect our ability to detect species. So if you want to learn more, come to my poster, and we'll talk about it. Thank you.